This is a demonstration of OpenTracing and Jaeger with microservices. We're going to be looking at what OpenTracing and Jaeger is, how it addresses the issues with distributed monitoring and logging for microservices. And we're going to be doing this using a Scrum management demo application, which is available on GitHub, and you can access it using this URL. So before we start looking at Jaeger, let's just have a look at the Scrum management demo application that we're going to be basing this demo off. You can see from our GitHub page it has a lot of instructions about how you can install this. Each microservice has a link from this page, so each microservice has its own repository, and you can link to that, and you can go in and see what the interface is for all of the microservices, and a detailed description about each of those. But if we scroll down from the main page, you can see this diagram that illustrates the architecture. And here you can see that the application is composed of 7 microservices plus a user interface. Now each microservice has its own database. So here you can see that what we've done is deployed a database server which contains a database for each microservice. And you can also see that we've got a message broker, and that's because the microservices primarily communicate with each other using what's called an interaction model. Now, to understand an interaction model, it might be a good idea to just have an examination of the types of interactions that we need in this application. Now, here you can see that we've got the business domain object called a story, which is managed by the story microservice. And here you can see that it has several states. It starts off as not started. When you add a task to it, it goes to planning. When you move it to a sprint, it goes to in progress. And when all of the tasks have been completed within that story, it moves to completed. And of course, this extends to other business domains. So, for example, if you look at task and you look at sprint and you look at project, they each have their own specific state. And in order to, because you have many microservices that are interested in the changing state of various business domains, then what we do is we broadcast those states using the message broker. So they subscribe to topics, and every time there's a new story that is created, that a JSON representation of that story is put onto a specific topic called, in this case it would be new story topic, and any other microservice that requires that event can subscribe to that, consume it, and perform whatever actions it needs. So, for example, if we look at creating a new story, every time you create a new story, we're going to need to update the project Burndown. Every time you create a new project, you're going to need to update a new project Burndown, things like that. And we can see those examples in more detail when we look at Jaeger. Now, this is a look at the simplified overall business domain model, and you can see the relationships between the domain objects. We have 2 reports in this application. One is I've already mentioned, called the Project Burndown report, and the other one is the Sprint Burndown report. So what this application does is demonstrate some of the core problems that we face when we're trying to build an application, and that is state transitions, data management, interactions between domain models, reporting, UI, all of those aspects of application design, or lots of those aspects of application design are modeled within this demo application, and of course are written using the microservices style. And so there is an inherent problem in that, and that each microservice, of course, is decoupled and it has its own set of log files. And it's very difficult to look at those log files and understand the flow of execution and where problems might arise. And this is one of the things that Jaeger solves. Now, to install this application is actually quite easy. If we scroll up here a little bit, there's a link from the main page for the demo application called Getting Started. So if you go there, and there's instructions on deploying it to OpenShift. I'm using Minishift, and you can see here that the installation is automated using Ansible, and there's instructions here about how to install Ansible on your Windows or Mac OS. Of course, it's a Linux application, so it's fairly straightforward to install it on Linux. And once you've done that, you can simply clone the Git repository and then run the Ansible playbook, and it takes about 20 minutes to complete. Once you've done that, if we go to our management console for OpenShift, you'll see that it will create a project called Scrum Management Demo, and inside of that you can see applications for each of the microservices, plus deployments for the database, which is Postgres in this instance, and the broker, which is AMQ, JPOS AMQ. So you can see all of that, and you can dig around and you can have a look at the logs. And what we're going to be doing is jumping between these applications and Jaeger to demonstrate how easy it is to use Jaeger. So you can start to see the problem that you face with a microservice architecture by looking at our demo application. In this application, we have 7 microservices plus a user interface. If we were to deploy this into a production system, the minimum that we would want is to deploy an instance of each microservice onto a different node and load balance across those instances. So you have 16 instances, microservice instances. Each instance will have its own log file, and by looking at the log file, you may be able to log out information about a specific business process. But what it doesn't give you is the context between the execution from one microservice to another. And that's where Jaeger comes in. What Jaeger does is stitch together the flow of execution across multiple microservices and give it to us in a simple to understand graphical user interface. Now, if we switch to our demo application, we can see that we're on the projects page here, and if we select one of these projects, you can see that it displays several bits of information. If we go into Jaeger, and we can see what it's actually doing under the hood. So here we've got timelines. So these timelines are essentially spans. Spans are units of work that are timed. And you can see that the entire operation for retrieving information from a project was 208 milliseconds. you can see that that it's named. So you can see that it's the basic UI. This is the name of the view that we used. You can see the URL. You can see the HTTP method, and each one of these spans has a selection of tags which contain all types of contextual information. You can see that the spans are hierarchical. So the top level spans shows us the total duration of that operation, so how long it took to request and refresh that particular view. But you can see underneath that it's calling the project API microservice. It's calling get project. You can drill into that. You can see the URL for that, the HTTP method, the HTTP status code, and so on and so forth. You can drill in further, and you can see the database query that was executed, and you can see the select statement here, the database user that was used, the type of database, the Java component. In this case, it uses JDBC. You can see that it needs to get the list of stories. So you can see here that it gets the information about the project, but it also needs to get the list of stories, and it needs to get a list of sprints. And you can see that it does exactly that here, and you can see the corresponding microservice, the queries that are executed here in the form of the tag values, and you can really get a sense of how an operation is broken down from a contextual standpoint. So it's worth understanding that OpenTracing is a standard, and you can go to their GitHub and you can see that their GitHub page provides many libraries for different languages. So it supports many different languages: Node.js, Java, Python, Go, many options, and it also supports many frameworks within those languages. So within Java, it supports J2EE, JDBC, JMS, Spring, most Spring Boot applications can easily be instrumented using OpenTracing. So once you've instrumented your application, or once you've installed whatever libraries you need to instrument your application, the data is actually collected by monitor, and that's Jaeger. So in our particular example, we use Jaeger to collect OpenTracing events, but there are other implementations such as Zipkin and Hawkula. OpenTracing is a standard. Jaeger is an implementation of OpenTracing that collects those events. So you can instrument your code using OpenTracing libraries, and you're not bound to a particular implementation of that. So you're not bound to using Jaeger to collect your events and generate your tracing reports. You can use any monitor. So let's look at an example that's a little bit more detailed. And we can do this by creating a new project. So several things happen when I create a new project. When a new project's created, we're going to publish an event saying, hey, I've just created a new project, and that will be the new project, the project microservice. Several things happen then. Firstly, we need a new sprint once we've created an initial sprint. So the sprint microservice will go, hey, I've just seen that there's a new sprint project. I'll create a new sprint. And when we create a new sprint, the sprint burndown microservice will go, hey, there's a new sprint, I need to create a new burndown chart for that. Similarly, when I create a new project, there will also be the project burndown microservice that will go, hey, there's a new project, so I'll create a new burndown chart for that. And we can see how that works. So I've created that. So we can go into Jaeger now and we can see what's happened. So this one up here is is something that we've seen briefly before. So that displays the project details. But what we're interested in is what happens when we actually create the project. And we can see that by looking at this new project submit. So what happens is that when I press the button on new project, when I press submit on that, it did several things. So it called the project microservice here, and you can see here that it executed several database statements. So it needs to find, it executes a sequence on the database to get the next ID, and then it can insert that into the database. You can see then that it publishes that event to a topic. So here you can see the address of that topic, and it says new project topic. And that's all it does within the project microservice. But then you go down here further on, and you can see here that here I've sent out this JMS message, and you can see some information about what happens to it. So here I've received that JMS message that corresponds to that topic, and you can see that I've got some contextual information in the logs about what that message was. So you can see that here I just put the new project onto the queue, and it gives information about the identification, the title, the number of sprints, all of the stuff that we added. And other information such as the destination and the component. So it's a consumer and it uses Java JMS. And then you can see what it does to it. So you can see here that it then inserts a new row into the database, into its database, and it also publishes a new event saying, hey, I've just created a new sprint, and we knew that it was going to do that. And you can see that I can drill down into any of these spans and look at the information, or I can collapse the whole thing. And you can see that similarly a project burndown is created, and it uses an API to calculate what sprints are required. So you can see that it actually calls another microservice to get that information, and then it has a number of database operations where it invokes queries to find the sequence, and it inserts rows into the database, and you can see what those rows are. You can see the SQL statements, so you can see what's going on underneath the hood, and that process is followed by each of those. So you can follow quite easily, and you could see when these operations happen. Of course, things like the Sprint API and the project burndown pretty much happen at the same time because they both intersect the same JMS message. But you can see that there are dependencies between these JMS messages. So when the sprint is created, it will push that message onto a topic, and the sprint burndown will pick that up. And you can see here that happens here, And then if you look down soon, just a little bit later, that message is intercepted, and you can see the details of that sprint. And this microservice goes away and creates a report for that. And we can see what that looks like. So if we go back to our application and look at a project that has a little bit more data, you can see that the project Burndown is automatically created here. You can go down and you can see that for all of the sprints, that you can see that the Burndown chart is created. You can see that different sprints have their own Burndown charts. And you can see that for the new project that we just created. So here there's no data created because we've not added any stories, but you can see that there's a project Burndown that was created and a sprint Burndown. You can access that sprint from the project homepage, or you can go into the individual sprint and add that. You can see that a sprint board is available. So there's a lot of things that happen just from creating that project. And what Jaeger does is allow you to easily contextualize and break down those operations and stitch it together regardless of how many microservices that you have and where they're deployed, what machines they're deployed on, and give you a story. And it's really valuable because then you can actually start to look at things like performance. Now, I mentioned before that the Scrum demo application has domain objects that have multiple state transitions that are also dependent on other domain objects that themselves may have state transitions, and this is true for things like stories. So if we look at the project that we just created, and we create a story, so we can just go in, create a story, and automatically generate the value, so it's fine. Notice that that story has a status of not started. Now, once we start to add tasks to that story, we expect that that story will be, that microservice will be notified that a task has been created for it by the task microservice, and that status is updated. And that interaction model is easily viewable within Jaeger. So let's go and have a look at that. So here I'm just going to look at the story. Let's add some criteria for that. But now I want to just let's go back. Notice that the status is not started. So I'm just going to go back, add the new task. I'll just refresh that. It might take a minute to update. And you can see that the status is now planning. So now let's go into Jaeger and have a look at what has happened there. So I want to have a look at what happened when I added a new task, a new story. So here I created a new story. Everything starts from the UI, so you can see this trace from there. You can see it calls that microservice. You can see that it populates the database and you can look at the SQL statements there, and you can see that it puts that a message onto a queue for the story that it's just created. And you can see here that once I create a new story, what I need to do is update the project Burndown, of course, because every time you create a new story, we want to add that to the overall backlog total so we can measure our velocity as we complete sprints. So here we can see that here, that it's set that the project Burndown is interested in that. And if we go back, we can look at what happens when I submitted the task. So the same thing happens here. I create a task, it updates the database, you can see the details here, it puts it onto a queue, and several things change here. That you can see that the sprint Burndown is interested when a new task is created, because it needs to update that particular report. And you can see that the sprint Burndown gets some additional information from other microservices in order to allow it to do so. You can see that the story microservice subscribes to that as well. So here you can see that it picks up that message, and you can see that message is logged, and it makes the appropriate database operations. Now, one thing to note is that with Jaeger is that you can get contextual logging. So you can see that not only do I understand what the queries are and what the what database is being updated and what the SQL being generated is, but I can also see what messages I'm receiving. And this example of contextual logging is really powerful, because most times when you're looking at log files, you don't have a context. You're trying to derive the context by looking at things like timestamps and your tailing logs, where you can't stitch together all of the things that you're interested in for a particular business operation. And you can imagine that in a production system, you may have thousands of these events occurring at the same time. But of course, OpenTracing is only looking at one specific trace at a time. So regardless of how many users are using the system, you don't need to comb through a specific log file or a selection of hundreds of different log files to understand what the context of each logging is, because you have it here. And that's really powerful, and it does allow you to diagnose problems very quickly. So this is an example of a really simple example of how this is used within the Scrum demo application. So at this stage, you're probably seeing that with Jaeger, you can get a contextualized view of a specific business process within a trace. But you're starting to see that actually you've got a lot of timings for each of these spans. You've got contextual logging for each of these. And then you can start to see that you can actually do some decent performance analysis, or at least some performance optimization. So if we go back to our early example where we created a project, so if I just go back there, and here you can see that this application is relatively unoptimized. Here we need to insert multiple operations, multiple rows in the database, and we're doing it in separate SQL statements. So in our particular example, we use something called Java JPA, but it could be any framework you want to use. And here you can see that here we're creating a project Burndown, inserting a row into the project Burndown table, and then you create a row for each sprint that that's within that Burndown report. And wouldn't it be easier to do that all within one SQL batch statement? And you could start to look at different operations within a microservice and start to optimize your code just by using Jaeger. And you can start to compare things like timings and see how your optimizations change over the time. So what Jaeger gives you is effectively a democratization for performance analysis. It allows developers working on specific microservice to optimize their code. It allows architects to look at a system as a whole and see how there might be different performance bottlenecks or misbehaving microservices or misbehaving queries. And you can do that by just looking at the timings. You may have specific SLAs that you want to measure, and you can see that, well, perhaps this query is responsible for missing my SLA for this particular operation because it's taking too long. And then you could start to dive in and optimize that code. So what happens when you've got a production system or even a testing system that's generating a lot of data at a particular point, and you want to pick out a specific trace or a specific set of traces, perhaps even for a specific project? How do you do that? Because as you can see here, just from what we've just done in this demonstration, there's quite a lot of data. And we want to pick out something for a particular project. Now what OpenTracing allows is something called tags, and we've already seen tags here. So if we go here and we click on any of these, we can see that there's different tags, but we can actually search by tags. So you can go here and you can see that OpenTracing gives an example here, and you can already see that I can filter by a HTTP status code. But say I want to find a operation, a trace for a specific story. Now, if I go back and I look at this story, I can see story 22, and I want to find all of the traces related to story 22. How can I do that? So I know that I've instrumented that in the application in one single place, and we can look at that later, and I can do a search for any trace that contains story ID 22 by adding this. So I go in and I can see that here that I've created here, this is where story 22 was created. You can see that, sorry, this is where the task was added for story 22. And you can see here that, if you go here, that when I submitted that task, at the very top, I've got story ID 22 here. And it showed me the entire trace for that. So by placing a tag in one single place, it will bring me back the entire trace. I can go back for any one of these traces that has this. And so this is pretty powerful, because what this allows me to do now is to pick out to be very specific in looking for traces. So for example, somebody may complain that they're working on a particular project and it was really slow. Well, it makes this by being able to filter by tags means that I can pick out from millions of traces and have a look at that and actually compare the timings and see what the problem might be. And that's really useful in a in a particular a specific production system, that's really, really difficult. Not only can I not find my find information from individual log files, because there are potential millions of lines in log files spread across hundreds of microservices, but I don't get timings for that. So I can add more tags to filter. So if I go back, I've added a filter for project ID 3, which is an earlier project. I think it was this one here. You can see by the URL. And if I look for those, you can see that it filters there, which is really powerful, because in a production system you can conceivably have millions of these traces, and you might want to pick out something specific, and you might want to do some performance analysis or some troubleshooting on a very specific query from a user. And by being able to add tags for contextual tagging information, and you can add it at a specific point in your application. In this case, it's always done in my examples in the user interface. I'd always add these in the user interface. You can see here that I've added this for the project, and I've where applicable, I've added it for the sprint. So you can see here that this project has a particular or this sprint, sorry, is related to a particular project, and you can see the ID of that. And it means that you can have fairly complex filtering, and which of course means that you can deal with large amounts of data. So very powerful there. So one of the common uses for logging and tracing is diagnosing the causes of errors, or at least understanding how errors might have occurred. And we can demonstrate that within the Scrum demo application. So one thing to note is that in our application, a business domain object has a specific state, and sometimes in in each of those states you cannot perform particular operations. If you do try to perform particular operations, it will generate an error. And in this example, it's actually possible to invoke deliberately one of these errors by adding a task to a story that has already been completed, and we can see what that looks like within the application and within Jaeger. So here we've got an old project, and you can see here that we've got completed sprints. So if I go into any one of those sprints, I can see which stories were completed there. And if I try to add a task, so that the UI doesn't stop me from adding stuff to this story. So if I go in and try to add a task to that, what I should get is an error, and I should see that error nicely contextualized for me within Jaeger. So here I've got an error page, so I want to find out what happened under the hood. Oh, wait a second, I need to remove that filter. Okay, so here is the trace that contains an error, and you can see here that straight away you can see that Jaeger has picked up that there's an error and made it very obvious. And you can see this icon here that says, hey, there's an error here. So I can go into this microservice, and I can click on the origins of the error, and I can see here that I've got contextualized logs that give me the stat trace. for that. And if I look at this, it's got a message here saying, cannot add a task to a completed story, which we know. And you can see that in the code, it actually throws a runtime exception. It gives a stack trace. And that's really powerful, because what it means is that I can quickly get to the source of an error. And by being able to being able to capture an error and contextualize that within a trace, I can diagnose problems a lot faster. Now, we're going to look at the instrumentation for this later on, but I can show you now that actually it's there was no additional instrumentation that I put in the code to make this happen. This happens automatically with the libraries that I've used, and of course your mileage may vary depending on the language that you're using and the libraries that you're using. So one thing I also want to show is going back to the filter for this. So I've been using this for application for a couple of days, and I know, and if I want to look at all of the errors that have occurred, I can actually, there's actually a tag for that. So if I go back to this and you look at the tags, you can see that what Jaeger does is that when it's detected that there's an error, it creates a tag called error and it sets it to true. And what that allows us to do here is to put that tag in and say, okay, give me back all of the errors for this application that I've seen in the last 2 days, and I can do that. So you can go through your entire application if you need to, and almost instantly get a list of your traces that contain errors, and have a look at how those errors occurred, which is of course really powerful if you've got hundreds of microservices, and not even hundreds of microservices. Even with our example where we've got 8 microservices, it's incredibly useful. Okay, so now we're going to have a look at how our code is instrumented. I'm going to open up Eclipse, which is the IDE that I'm using to write all of this, and we can have a look at this. Now, it's important to understand that the immediate benefit of implementing OpenTracing is trying to get as much coverage as possible on your code base. The more coverage you get for free, the quicker OpenTracing can be adopted and more useful it is. Of course, the OpenTracing API can be added for any application, any Java application in our case. The real advantage is really how much instrumentation you get out of the box. Now I'm using Spring Boot to implement each of these microservices, and I can show you that for Spring Boot, which is quite an easy application to use, it's really simple to add instrumentation. If I just open up the POM XML, you can see that I add libraries for OpenTracing and Jaeger here. And pretty much that is it. One thing to note is that I'm using the Spring Cloud library for OpenTracing. So what that gives me, if I just go here, I can have a look at Spring Cloud. So you can look at, it's actually a pinned repository. Spring Cloud, if you're using a Spring Boot application, then the Spring Cloud library is really what you should be using, because out of the box you get instrumentation for REST controllers, templates, Spring MVC controllers. What that means is that every time you click a link to go to a view, it will automatically instrument that. There's no code in that, and I can show you that. So if I look at the UI, and you can see that I've just hit the story view. So if I go here and you look at the story controller, and you can see that this is the view that renders the story page view. There's nothing there. It is just application code. So the application code is kept really clean, but at the same time, if I just filter that, you can see that it gives me a clean trace of what it's happened and what it needs to do to actually build that page. Now, however, if I need to add tags, as we've seen many times, to enable me to filter stuff, it's also very easy. In Spring Boot, the application is configured by creating a Jaeger tracer. So here in my code, I create a tracer instance. If you notice here, I give it a name, so basic UI, and that will correspond to the service name at the top here. So this corresponds to the tracer. Yeah. And I also say configure that tracer and say that all of the configuration parameters are defined from environment variables, and we can see how that's done in a minute. What the instrumentation will do in our example is it will decorate any component that it recognizes that it has an instrumentation class for. So for the UI, you can see that it uses this REST template, and one of the things that I do is I make sure that every time I use a REST template, I inject that REST template into all of my classes. And what that means is that Jaeger can easily instrument that. It's actually possible to create classes where you instantiate those REST templates on the fly, and were you to do that, you wouldn't be able to get instrumentation using OpenTracing, and you would have to manually instrument that REST template yourself, or at least add the code to instrument that yourself. So there are patterns that for Spring Boot at least that are more optimal to allow you to get better coverage, but as long as you're aware of what those patterns are and how the underlying API works, it's quite easy to follow. So here you can see that in our example, we create a bean which implements this IO OpenTracing tracer for Jaeger, and that is injected. That will be injected into any class that requests it, and you can see here it's auto-wired. And then what we could do is we can then use that tracer to add our own specific tags. So anytime we use a project or we call a project, here is where I add the tag to the active span. And that's all this is the only manual instrumentation that I use in the entire project. And if you look at so this is for the UI. If we go and look at more sophisticated examples, so for example the Burndown reports, which of course have JMS listeners and JMS receivers, you can see that the dependencies that we add, they're exactly the same. The only difference between these more complex examples are the code that we need to define our instrumentation. So you can see here that I create a tracer in exactly the same way in all of my applications. I expose the REST template builder because I want all my REST templates to be decorated with by the OpenTracing API. But I also create a JMS template which I decorate with the OpenTracing API. So this is the only additional concession that I make for OpenTracing to allow the decoration, and that enables me to intercept calls for JMS receive and JMS send messages to queues and topics. And that's it really. That's all that's required. There are some gotchas, but we'll cover that in another video. Next, what we're going to look at are the configuration parameters for Jaeger. Okay, so you notice that when we create our tracer, we configure it using in our particular example, we configure it using our environment variables. So to look at how these are configured, I'm going to go back to OpenShift. I'm going to look at the environment variables for each of the microservices, and you can see that each microservice has an environment variable that relates to Jaeger. So these ones actually point to the the host connections, but the things that are most interesting are the samplers and the sampler types. Now, you can imagine that if you have millions, possibly billions of these tracers on a daily basis, perhaps most of them are, well, the vast majority, 90% are identical. 99% are identical. So you may want to monitor your production system. You don't want to collect all of your data, and you can define different sampling schemes. So in our example, we sample everything. So we you can see here that the sampler type is constant, and we sample every single one of them. This sampler param is a one-to-one relationship, so it's a probabilistic parameter. But you may want to sample 1 in 3 or 1 in 2, so you could change that to 0.5. And what that means is that you have a lot more control over how you collect your data in a production environment, so you don't overwhelm your monitoring database. And this can of course be tuned for any environment. So in some environments you may want monitoring that's on all of the time. Sometimes you only want monitoring for a certain period, or you may want to limit that sampler rate, or some applications may need monitoring and some applications may not need monitoring, and you have a certain degree of flexibility within Jaeger for how you can actually tune that. So the second thing that often gets asked is, what is the performance cost of adding this? Now, I haven't actually measured this, but what Jaeger say is that the performance cost is less than 1%, and that seems fairly reasonable to me. One thing to note is that when you add instrumentation for Jaeger, if Jaeger isn't running, no error messages are generated. If it can't connect to Jaeger, the API will say, okay, Jaeger's not available, and won't send any messages. So it won't block and hold up your application while it's trying to find a Jaeger agent and which it can actually connect to and send messages to. So it's actually possible for developers to put this into their code and not have Jaeger running locally and not worry about it at all. So it's very flexible in how it can be used. So I think that concludes everything in this demo. If you've got any questions, you can add those questions to our GitHub under the issues section here, and I hope you've enjoyed this, and I hope you've learned something from it, and I'll see you next time. Thank you very much. Bye.